Good day, Alg 1B kids. I hope you're enjoying the day. Today we are going to talk about absolute value inequalities, but before we get into that, I want to talk to you quickly about absolute value equations because you have to understand how absolute value equations work before we can understand how absolute value inequalities work. So remember from the other day, before break, and also when we did the review, the extra practice, when we're solving absolute value equations, what we're talking about is we're talking about a distance from zero. So remember that however far away you are from zero, it's always going to be a positive number. So if the absolute value of x equals 4, that means the distance that x is from 0 is 4 spaces, which means there's two different places that x can be on a number line. It's either at 4 or negative 4. And that's an equation. That is equals to, that means exactly 4 spaces away from 0. And what that results in is once you get your absolute value by itself and that x plus b in absolute value bars, that guy right there, when you get that format, that's when you know to split essentially your absolute value equation. That's when you know to say, okay, well, whatever's inside these absolute value bars is c spaces away from 0. So it's either at positive c or negative c. So it's kind of the same idea with inequalities, but it's not exactly 4 spaces away. It's either more than 4 spaces or fewer than 4 spaces. So let's get into it, and hopefully we will remember how to do the equation stuff and when we get to the inequalities. Okay, so quick remember that the absolute value of x equals 3 means that the distance between x and 0 is 3 spaces. So that means you are either at positive 3 or negative 3 on a number line. The inequality, the absolute value of x is less than 3, means that x is less than 3 spaces away from 0. So that means it's in between negative 3 and positive 3. So I hope that this makes sense to you. So here is your negative 3 value. You can see it right here. Here's your negative 3. Here's your positive 3. All of the spaces that are less than 3 units from 0, something like 2 or 1 or 0 or negative 1 or negative 2 or 2.5 or 2.99999, all of those values are less than 3 spaces away. Okay. If I go out to 4, 4 is not less than 3 spaces away from 0. So that's why 4 is not part of our solution. Okay. So conversely, the inequality, the absolute value of x is greater than 3, means that the distance between x and 0 is more than 3 spaces. So exactly 3 spaces is going to put me at negative 3 or positive 3, but what it's telling us is it's more than 3 spaces away. So more than 3 spaces could be 4 spaces. So like at 4 or negative 4, or maybe 3.5 spaces, or maybe 3.0001 spaces. Okay, but it's more than 3 spaces away, so it's farther away. Essentially what this boils down to is when you have less than or equal to, this is going to be an and inequality. If you have greater than or equal to, this is going to be an or inequality. So this is why we do compound inequalities and absolute value equations side by side, because you have to know how to do both of those to do absolute value inequalities. Okay, so to solve these guys, the concept is exactly the same as it was with absolute value equations. You need to get your absolute value bars alone first, so you have to get this stuff by itself first. Okay, and then we'll go from there. So the inequality where the absolute value of ax plus b is less than c is equivalent to the compound inequality. All this is saying, this right here, is saying the same thing that I just set up there, just in a little bit of a fancier way. And this right here, when you have a greater than, it's going to be an or inequality. Okay, so it's always going to have that or in the middle. Remember that if it's an and inequality, we are going to write it as an inequality that has two actual inequality symbols in it. All right, so we're going to do about 5 questions today. And then the next time we meet, we're going to do some word problems, some applications of it. Okay, so keep in mind, we're putting together what we learned with compound inequalities and also absolute value equations, and we're going to do them together, essentially. Okay, so number 1, I'm going to zoom in here. It says solve each absolute value inequality and graph your solution on the number line. Okay, so we're going to follow the same set of steps that we did before. So I need to get my absolute value bars by itself. Whatever's in absolute values, I want it alone. This guy right here, I need it by itself on the left side of the equal sign. It is not by itself, so I have to add 4 to both sides to get it by itself. So the absolute value of 2x plus 3 is by itself now, is less than or equal to 9. So what that's telling me, I want you to think about this in terms of a number line, just like we did with equations. Okay, let's pretend like it's equals to 9. Okay, so here's your 0. That means you're at either negative 9 or positive 9, right? Okay, so since my inequality arrow has an equals to sign on it, this right here means that I'm going to have filled in circles. Okay, the equals to means filled in circles. Now, where are the spots on my number line that are less than 9 spaces away? So if I think about this, where are the spots on my number line that are less than 9 spaces away? Well, if I come out here to 10, 10 is more than 9 spaces away, so that's not where I want to go. But if I look here at 8, is 8 less than 9 spaces away? It is. What about negative 1? Is negative 1 less than 9 spaces away? Yeah, it's 1 space away. So yeah, that's it. So that means 2x minus 3 has to live in between these two values, right? So negative 9 is less than or equal to 2x plus 3 is less than or equal to positive 9. I want you to see how the number line guides you in the construction of your inequality. Okay? Now, this at this point should look extremely familiar. This is exactly what we did with solving compound inequalities. This is solving an and compound inequality. So from here, we're going to subtract 3. Remember, I did these little dots here. You have to do subtract 3 on all 3 pieces. Okay, so I'm going to have negative 12 over here on the left is less than or equal to 2x is less than or equal to 6. The last step here, we're going to be dividing all of our things by 2. Okay, so I'm going to get negative 6 is less than or equal to x is less than or equal to 3. What I want you to notice is negative 6 on the left, positive 3 on the right. That looks exactly like my number line if I were to put these on my number line. Negative 6 would go here, positive 3 would go here. Okay, so you should be able to go negative 6 is less than or equal to x is less than or equal to 3. To put your solution on your number line, it's the same way we did it with solving a compound inequality. I have a solid dot at both negative 6 and also positive 3. And x is in between these values, so you're going to fill in the stuff in the middle. Okay, and then this would be your final answer. All right? The only thing that's really, truly new is basically this part right here, where you're taking your absolute value inequality and turning it into a compound inequality. Okay, let's do another one. Number 2, 5 times the absolute value of 1/2 r plus 3. We have to solve this exactly the same way that we did before. So we're going to divide both sides by 5. And I get the absolute value. Whoops, I don't want to do that color. So the absolute value of 1/2 r plus 3 is greater than 1. So what we have here is we have 1/2 r plus 3 is more than 1 space away from 0. So if we put this on our number line, okay, our original, we'll start with this part. One space away from 0 is -1 and +1. Okay. We have greater than one space away, not greater than or equal to. So that means I am looking for open circles here. Open, open. Okay. 1/2 r plus 3, if it's more than one space away from 0, farther than more than one space away is either over this direction, because 2, 3, 4, 5, so on and so forth. Those are more than one space away from 0. On the other side, the opposite side of the number line, -2, -3, -5, -10, those are also more than one space away from 0. So what we're going to do is we're going to take our graph here, our picture that has our little 1/2 r plus 3, and that little cloud has got to live in one of these places. So this piece here is telling us that 1/2 r plus 3, if I look at my arrow, is less than -1. That's what that is telling us. Okay. This right here is telling us this is 1/2 r plus 3 is less than -1. Okay. Now we're going to look at the other side. Our little cloud thing here, we said that that was 1/2 r plus 3. My arrow points greater than 1, so greater than, not equal to, because it's not a filled in circle, it's just greater than 1. This is an OR inequality. Okay, we saw in the original one, once we got the absolute value, inequality sign, number, we had the absolute value is greater than a number, so that means it's going to be an OR inequality. So for each one of these, we're going to solve. Okay, we're going to subtract 3 on both sides. So I have 1/2 r is less than -4. Let's see how many of you know what to do next. I'm going to give you a second to think about it. You can divide both sides by 1/2 or multiply both sides by 2. I enjoy that a little bit more than dealing with fractions. So r is less than -8. Notice I did not switch the inequality arrow because I did not divide or multiply by a negative. Yes, my answer is negative, but I did not multiply or divide by a negative number. Okay, so on the other half of this, I'm going to follow the same kind of idea. I'm going to subtract 3 on both sides. Okay, so I'm going to have 1/2 r is greater than -2. Same steps here. I'm going to multiply both sides by 2. And that's going to give me r is greater than -4. Okay, so here is our inequality written out in inequality format. There we go. Love that for us. Now we're going to put these on our number line. So my two boundary points are -8 and -4. If you think about a number line, -8 is going to be farther to the left than -4. 0 is going to be over here. We're kind of zoomed in and scooted to the left of our number line. Okay, less than -8, less than is not equal to, so open circle, we're going to go to the left. This inequality graph I'm putting above my graph. It doesn't matter if you put it on your graph like I did in the last problem or above like I'm doing here. It does not matter. I can tell both. Okay, so there's your answer for that one. So any r value you choose that's greater than -4 or less than -8 will make that inequality a true statement. Okay, I'm going to do 3 more a little more quickly. Hopefully you're seeing how we're putting our compound inequality work together with our absolute value equation work. And we're kind of meshing them together to make one big problem. Okay, number 3. Let's take a look at number 3. -2 times the absolute value of 6x minus 1 plus 5 is less than 3. So we got some work to do here. We have to get our absolute value by itself. This right here needs to be completely alone before I can split it up. So we have a little bit of work to do. So I need to subtract 5 on both sides first. Remember, when you're solving, you're going to do PEMDAS in the opposite order. Okay, so I have negative 2 times the absolute value of 6x minus 1 is less than, that's going to give me a negative 2 over there. And some of you might be like, hold up, absolute value can't be less than a negative. We're not done yet. We still have negative 2 times our absolute value, so I still need to divide by negative 2 on both sides and also switch my inequality arrow. I divided by a negative. Okay, so the absolute value of 6x minus 1 is now greater than 1. Okay, so we are looking at the absolute value of 6x is greater, 6x minus 1 is greater than 1. So that means if I come to my handy dandy trusty number line and I take a look at this, here is 0, here is 1, here is negative 1. I am looking for more than one space away from 0. So on the positive side, more than 1 is anything bigger than 1. On the negative side, it's less than negative 1. So those are going to make up my two inequalities here. Okay, so that means 6x minus 1 is either going to be here or it's going to be here. And I'm going to use this information to make new little inequalities. So 6x minus 1 is less than negative 1 for this piece right here. And I'm going to do the same thing for this piece over here. 6x minus 1 is greater than positive 1. So on the left side inequality, I'm going to add 1 to both sides. Okay, and I get 6x is less than 0. Does that mean the answer is no solution? No, it doesn't. Because when you divide both sides by 6 here, 0 divided by 6 is still 0. 0 is a valid number. X is less than 0. So any negative number you choose will make this work. Okay, we're going to come over to the other side here. We're going to add 1 on both sides. I'm going to get 6x is greater than 2. Then we're going to divide both sides by 6. And then some of you are going to freak out and be like, but miss, it's a fraction. Yeah, and x is greater than 1/3. Fractions are okay. Okay, on a number line, 0 is going to be to the left. 1/3 is more than 0. So it's going to go to the right. X is less than 0 goes this way. X is greater than 1/3 goes this way. And there's your answer. There's all of it right there. There's a whole bunch of little bits and pieces there. There's your two inequality pieces. And then here is your graph. Okay. Next one. We got this one and then one more. Number 4. So this one requires just a wee little bit more work. That's okay. We can handle it. We know what we're doing. We're going to subtract 10 on both sides because don't forget, you have to get your absolute value. This guy has to be completely alone. Right now, not alone. So we're going to subtract 10 on both sides before we do anything else. Okay. So we have 2 times the absolute value of 4x minus 7 is less than, what's going to be a negative 9. Then I'm going to divide on both sides by 2. So I get the absolute value of 4x minus 7. Whoops, that's not a 7. Minus 7 is less than, that's going to be negative 4.5. You can leave it as negative 9/2 or you can change it. At this point, how far away is negative 4.5 spaces from 0? Your answer should be, this is no solution. Okay, this right here, here's your little exclamation point. No solution. And why is it no solution? You should be figuring this. You should be kind of saying this in your head as I'm saying it. It's no solution because the absolute value is either 0 or a positive number. The absolute value cannot be negative. So 4x minus 7 can't be negative distance from 0. Okay, so it can't be negative distance from 0, not possible, so this is a no solution. Just leave your number line blank and give me a big fat 0 with a slash through it. Okay, last one, describe and correct the error. So what I want you to do is I want you to pause this video and try to figure it out. Okay, so pause this video and try to figure it out. And when you're done, hit play. Okay, I hope you were able to take a look at this and figure it out. So I have the absolute value of x plus 10 is greater than 25. So this right here, I have the right format. I have ax plus b. I have is greater than c. Okay, this is going to be an OR inequality. That's great. So if I kind of think about it numerically, or on a number line rather, I'm going to have negative 25 to the left, positive 25 to the right. So more than 25 spaces away means I'm going this way, or I'm going that way because 0 is in here in the middle. So that means I should have x plus 10 is less than negative 25, or x plus 10 is greater than positive 25. In this case, the person answering this question set it up as an AND inequality. And this should be, or this is, an OR inequality. Okay, so it should not, there's the mistake is right there. So it should be like this. Okay, so we would subtract 10 on both sides and we'd have x is less than negative 35, or x is greater than 15 would be the answer in that one. Okay, your assignment for tonight, or what I would like for you to do to practice this before tomorrow or the next time I see you, is I want you to do page 102 and 103. So 102 to 103. And we're not going to get into the word problems right now. We'll get into the word problems tomorrow, because it takes a minute to kind of to set those up and get comfortable with them. So what I would like for you to do on pages 102 and 103, it's not going to take you too long. And I don't always give you homework, but you're going to have numbers 1 through 12 tonight. Okay, so number 13 is when the word problems start. Do not do those. But I want you to complete pages 102 and 103, numbers 1 to 12. Okay, if you have any questions, you can, reach out to me. I will try to get back to you as soon as possible, or we can just discuss it in class next time I see you. Otherwise, enjoy your day. Stay safe, make good choices, and love you. Bye.